So, what is the reason for the seasons? The reason for the seasons is that the Earth is tilted on its axis. It has a 23.5-degree axis, the point on which it spins. And because of that, Earth gets different amounts of direct sunlight. So it's not enough to say that the Earth spins on its axis to say that it has seasons. It has to be because it is tilted, right? Or tilted. Because of that, that's why we have seasons. And you can actually see right over here. Now, this model is imperfect because the Earth is so similar in size to the sun. Doesn't really matter because what it's showing us is that you see how this red part is always pointing either away or towards the sun, depending on where it is. So that means that half of the year it's generally pointed away and half of the year it's generally pointed towards it. Because that gets different amount of direct sunlight, and that amount of direct sunlight translates into the amount of heat that it's going to get. So you can see right here, as the northern hemisphere is tilted away, it gets less of those sun's rays. Let's say it has 3 of these sun's rays coming this way. Those 3 amount have to be spread around the entire amount over here. Whereas now, the southern hemisphere has 1, 2, 3, 4, 5, 6, let's say 7 of these rays all coming towards it. So it's getting a lot more heat during that time, and it doesn't have to spread it around as much, I guess you can argue. So this is why we have the seasons. And actually, in winter, just imagine your perspective over here. If it's tilted away and this is your winter and you're looking over here, the sun is going to look like it's much lower in the sky right over here, right? Whereas if it was tilted towards it, it would look like it's higher up in the sky, the sun every single day. So all of those things factor in depending on whether or not it's winter or summer. Now, when it comes to fall and spring, then you're getting more equal amounts. And that's why it's generally not that different in terms of the weather in both the fall and the spring, at least from where we are. It just happens to be that one is gradually getting colder and one is gradually getting warmer. So you can look over here. If we're in the northern hemisphere, we're tilted away, and then that would be winter here. But because we stay always tilted in that same direction, sorry, I have to do it backwards over here so you can see, and then it will come over here on the other side. Then we're tilted towards it, then it will be summer. And as we have our summer, right, at the same exact time, everybody in the southern hemisphere is having their winter. So when you say, oh, the weather in August, you know what that's like? Well, it depends on where you're from. Not exactly. So if you're in Australia, right, and you're celebrating Christmas, right, you might have like a really hot Christmas day because that wouldn't be that weird for you to have it. That would be like one of the hottest days in the year possibly for you. Now, if we look here, let's see if we can fill this out, okay? We have 4 different dates, okay? And let's start with all the way over here. We have the northern hemisphere tilted away. That would, of course, mean that this is what? That would be the winter solstice. It happens on December 22nd, roughly. Sometimes the days between the 21st, 22nd, and 23rd can get a little mixed up depending on the year. But in general, December 22nd, winter solstice. Sol means sun, right? So that's what it means in Spanish, and I believe it is Latin as well. If there had to be a name for our solar system, for our sun, it would be Sol. Every other star has a name. Ours is just the sun, but if you had to call it one, it would be Sol. And solstice, stis means stop. So it's kind of meaning like the sun is stopping halfway in between, and it's like it looks like it stops in the sky. That's what it translates to. So we have winter solstice. After winter, notice where the arrows are pointing. It's not going up in this way. It's going down and to the right. So when it's coming down and to the right, our next 3 months later, because if you had to if it takes 12 months for it to go around the year, then we have 4 different stations and they're equally proportioned out. It will be 3 months later. So what would this be for the 21st? If you said March 21st, you are correct. So this would be the spring, or sometimes called as the vernal equinox. So equinox means equal. So equa, like it means equal. And then nox, nox. So nox comes from a German word that means night. And if you are a Harry Potter expert, you might know that the spell Nox is the opposite of Lumos. Lumos turns on the light on the wand, whereas Nox turns off the light. So it's kind of like nighttime, right? So it means equal night, equal day. So on the days of the vernal equinox, you have an equal amount of sunlight and darkness, evenly proportioned. Whereas if it's like really, if it's a summer solstice, as we're going to get to next, the summer solstice would be on June 22nd, right? Our days are longer. Now, we don't mean days are actually longer in the sense of like all days are 24 hours. What we mean is daylight. So you're going to get many more hours of daylight than you would. And on the summer solstice, in general, that is going to be the longest day of the year, meaning that the sun is just out shining longest before it turns to nighttime. And then finally, we have the autumnal equinox. Happens during autumn, September 23rd, roughly. And again, you're having equal day, equal night, but it's heading towards the colder time, right? And if you think about it, right, this whole thing represents 1 year. Your birthday is just a celebration of how many times that the planet, our planet, has made a revolution around our local star, the sun. So that's every time you're celebrating a birthday. That's all that is. All right. So let's think about this. This is a hypothetical scenario, meaning that it's not going to happen, basically, but it still could be fun to think about. So what if the Earth was tilted even more on its axis? So here we see it's tilted about 23.5 degrees. What if it was tilted like an additional 26 degrees? Well, how would that impact the following things? The height of the sun in the sky. Well, we already said that in summertime, it looks like the sun is higher than it is in the wintertime where it looks like it's lower. That would be a lot more dramatic. There are some places in the not in the United States, in the world, where when it's wintertime, you just don't see the sun for about 6 months. So a larger chunk of the world would experience that, where the sun would just be gone and then it would be there. And in some places, when it's there all day long. So it would be like you could have 24 hours of sunlight. So if you live in an area like that, you need to have like blackout curtains or something to make sure that you can actually sleep. So you can simulate the nighttime, because we're used to sleeping when it's dark out. That's how our bodies are biologically programmed to do that. And when we see sun, or if you see like the screen on your phone, right, then that simulates sunlight, and that's what keeps you up. So yeah, the height of the sun would be drastically different. Remember, it's going to be way more intensely tilted to one side, as you can see over here. So the length of the day, again, still will be 24 hours, but you would have an incredibly long daylight, like what we were saying, in terms of the amount of time that the sun is out compared to the entire length of the day. The temperature of the seasons, we would have much more intense seasons, meaning that in certain places, it would just vary a lot. So it would be really, really hot compared to being a lot more colder when it was faced away. And then the last thing would be life and ecosystems. Who knows if if it just randomly happened? By the way, this can't just happen where I would all of a sudden just tilt a little bit more. That wouldn't just happen. Unless we were like pelted by a gigantic asteroid or something like that. And even then, that would probably destroy a big chunk of Earth. So I wouldn't be worried about that. But our ecosystems would have to adapt. And in all likelihood, all the animals that are here on Earth would have been adapted to the way it is anyway. So, I mean, they're adapted to the way life is now. But if life was always that weird, always changing, either the animals would be perfectly adapted to that, where they wouldn't be specialists, they would be more generalist, right? You wouldn't, a polar bear that's like ready to exist in the cold is not adapted to live in really hot areas. You don't see a polar bear in the jungle, right? But the types of animals that can survive in all different ecosystems would be the big winners in this one. And it's possible that it would just be too intense that most animals would not be able to withstand it. And therefore, maybe life wouldn't have evolved in the same way. So it's good that we have the seasons and the life that we do, because if there was no tilt on the axis, then we wouldn't have any seasons. And then it would just always be the same weather all throughout. So imagine like the most middle day of the year for us here would be, I don't know, let's say a day in spring. It would just be like that all the time, where you would have just like, and that's really what happens in the equator. It's pretty much always the same weather. It's either wet or dry. Those are the seasons they have compared to true winter and summer, like the way that we have all the seasonal differences.